I wanted to introduce Git and GitHub, specifically in the context of working on a software team. And I know a lot of you guys, especially if you've done 3000s or 2000s, have worked with Git on some sort of level. But generally speaking, you're working with a small group of people and you guys are all in the same room. So the benefits of Git aren't necessarily obvious. And I wanted to introduce specifically how Git and GitHub and how you can use these two tools when working on a software team. So I'm going to do a really quick Git overview. So to clone a new repository, you get clone, updating your local repository, obviously git pull. Some of the more specific ones would be like creating a branch, checking out a branch, and checking out a Git hash. All of those are just Git checkout, as you can see right here. And obviously, if you need help with something in terms of commands, you can just do git help, and it'll give you a little help with the command that you're looking for. So GitHub has a fantastic project management system. It's split into two things. It's called GitHub Issues and GitHub Project Management. There are two examples right here. Both of these are taken from the project management github.com page. You can see this link down at the bottom. And we're gonna go through both of them. Now, I want to preface this that you don't necessarily need to use these, but I highly recommend that you do, especially since you guys are working at like long distances from your group partners. So we'll start first by going through GitHub issues. So what is a GitHub issue? GitHub issue is like a project management system that's designed to help keep track of your bugs and tasks that you're trying to do. So as you can see here on the right, we have an example issue. Now, issue is kind of a misnomer because it's not necessarily an issue with your code. It could also be a feature or request for documentation or something like that. We'll talk about labels a little bit later. So there are a bunch of different things on the side here. We'll go through a few first. The first one we'll go through is assignee. An assignee is the person who's tasked to complete a certain issue. So if you guys define all your tasks and you want to say, hey, Joe, I want you to do this task, then you can give that person that task and it'll show up really nicely inside of GitHub when they open up github.com. A label, as we'll go through, is a type of issue. Some of the types that are by default are bugs, features, documentation. I usually use bugs and feature. Documentation is super useful when you're using these features in a much larger scale. And finally, you'll see here linked pull requests. Especially when you are working with team, and we'll go over it a little bit later, pull requests are extremely, extremely useful, and I highly recommend that you guys use it instead of just merging code into your main or develop branches. And we'll go over all of that in a bit. So I want to give you guys also a few tips and tricks on how to use issues correctly, or correctly in my eyes, because there are a lot of different ways that you can use it. If you're ever reporting on a bug, make sure you include how to reproduce that bug and how serious it is. I cannot tell you how many times I've been on an open source project and someone has said, like, this doesn't work, and I'm like, well, how doesn't it work? Or like, how did you make it not work? Because I can't reproduce it. And if you can figure out how to reproduce it, it will drastically increase the likelihood of you being able to fix that bug or someone else being able to fix that bug for you. This is especially important if the bug is in someone else's code. For features, if you're ever creating a feature, make sure you include a few things. One, the description of the feature. How do you test the feature, and what tasks need to be completed before the feature is complete? And we'll go over that in a bit, but I want to really stress how to test the feature. Testing, if you essentially create your test suite, the test that you are going to run to determine if that feature is working or not, before you start working on that feature, you don't necessarily need to write test cases or anything like that, although that is a valid way of doing it. But just saying, like, I will be testing it using this, this, and this method. Or these are the lists of the tests that I will be completing, and if all those tests are complete, then that means the code is working. And I really, really want to stress that that is super useful, a lot more useful than you actually think it is when you first start out. And the final tip is don't forget to add your issue to your pull request. So in any documentation, whether that is in another issue or in a pull request, you can add the pound or hashtag and the issue number, as you can see here, and it will essentially give you the it'll link your issue that you are with that issue number back into your code, so that you can like just click on it and then you can look at that issue. And as you can see here, you can see the issue number. This is issue number 1, right next to the title on every single issue. So with that, I'm going to I would like to do a let me see. There you go. I would like to go through an example. So I've created, can everyone see my screen? I've created here a, essentially a GitHub demo. It's very, very rudimentary. And as you can see here, this is the code that you will be using for, this is the example code that you'll be using for your final project. So it's somewhat relevant. Anyway, issues is right here. There's a tab that it's clicked issues. You click on it, and I've created 2 issues, a feature and a bug. Let's first go into feature. As you can see here, this is an example feature, and you see the feature number right here. And I should, if I would like to assign someone, I can assign someone inside the project. That would be me or someone else. I could just search it up, whoever's inside the working with in the project. And then right here are some labels. If you click this, then you could see all the different labels that you have here. A lot of these you'll almost never use unless you're working on a very large open source project. But the main ones that you want to look at are feature, bug, and documentation. Now, if you would ever want to add or change labels, you can click edit labels, and it'll open up to this, and then you can add different labels and whatnot, and change them and create add descriptions or anything like that. Now you see here, this says that it's a part of a project, example project. We'll go over that in a short bit. And then you could also click link pull request. And right now I don't have any open pull requests, so I can't necessarily link to it. But another way to link the pull request is to just say add the pounds to or the hashtag to in somewhere inside of that pull request, and it will automatically link this to that pull request. It's also super cool because once you merge that pull request, it will automatically close this tab or this issue. So in here, I added a few examples. So like the issues and tips that I put in the slides, you can see them here. So make sure you implement a description. For example, a description would be, I would like to move the robot base based off of desired base velocity. The input message will be command velocity. And you'll learn a little bit more about all of these message types and whatnot as you get through ROS. Another thing, a good practice is to insert your testing methodology before starting on the feature. Like I said, make sure you add your tests before you start. It will make your time easier and make sure you have less bugs in your code. So some example testing methodologies, I will be giving a robot a vector and make sure it goes in the correct direction at the correct speed using a protractor and a radar gun. That's not necessarily applicable to all situations, but you know, that's an example of a test. The second one will be, I want to test out of bound inputs of speed and direction. For example, if I say 380 degrees and 1,000 meters per second, my robot's not going to go 1,000 meters per second. I want to make sure that I have out of bounds and it doesn't, my system doesn't crash or a bug is arisen just because I've given it something I'm not expecting. Those are 2 example tests. I really, really do stress though, it is worth your time to sit down and think about all of the possible tests that you can do because it will drastically help you as you are developing your code, especially when you guys are working at a larger distance like you are right now. And finally, if you'd like to add some tasks, I've always found that is super useful. It helps your group members keep track of how far you are along with your issue instead of you guys just pestering each other and asking, oh, are you done yet? Are you done yet? You can actually see exactly how you're done. So for example, I'm going to create a skeleton node that communicates with the other nodes, and then I'm going to figure out forward and inverse kinematics, and then implement forward kinematics, and then test the robot. And as you can see, you can uncheck or check certain things, and it will stay checked. And then also, when you look at that I'll show you in a bit. When you see it, it'll show how far. As you can see, 2 of 6 tasks are done. And I always like to put my tests also as tasks so that they're easily checked off to make sure that I finished all the tests. Okay, so we're going to go through an example bug. This is a lot less, more fluid, and you can add whatever you want in there. But the main things that you need to implement is what is the bug? What's wrong? What happens? Are there any error messages? Please put the error messages in there. Secondly, how do you reproduce the bug? How did you get to that bug? And sometimes it's extremely hard to figure out. And in those rare cases, you can't necessarily say that you can reproduce the bug consistently, but at least try and at least say that. Say like, hey, I cannot reproduce the bug consistently, but I think it's because of this, this, and this. It helps out significantly. The more information, the better for when you are actually trying to tackle and squash that bug. And third, I usually like to add this, but how serious is this bug? Is it something that will crash the whole computer? Is it something that is unexpected? For example, the robot turns left instead of turning right, or is it hard to notice at all? Is it something that is minor and doesn't necessarily need to be tackled right away? It's always really nice to know so that when you are looking through new tasks to complete, you can see, oh, this isn't that important. I'll do the other one that crashes the computer instead of this one that's hardly noticeable. And right here, you can see here relates to number 2. And all you have to do is just put the hashtag 2 in there. And then if you hover over, it will show you like a little description. And then if you click on it, it will bring you to that other issue. So it's super useful to be able to link back and forth. Okay. Okay, so we're back here. So let's talk a little bit about GitHub Project Management. As you saw earlier, I had an example project. I called it example project. You should call it whatever you necessarily want, but there are a lot of different ways to do project management. One of my favorite ways and one of the most popular ways is a Kanban style of project management. And it's very simple. It's used with a bunch of, you use a bunch of cards, for example, like these, and then these cards could be placed in to do, in progress, and done. Now you can have like low priority to do, high priority to do, all of that's necessarily up to you and your team, but the most simple way is just to do, in progress, and done. GitHub Project Management makes it super easy for you to do this. You can add specific issues, or you can create your own specific card in each one of those sections. You can just click the plus buttons up here. And it's helpful to keep track of all of your tasks that you have to do, both issues and tasks that you have to do as a team. Now, there is also some automation. As you can see bottom, it's kind of darkened, but you'll see it more obvious if you ever play around with it. Automation, it has built-in automation that'll allow you to auto-add projects and automatically move things from in progress to done. For example, if you merge a pull request and it's merged into master, it's super useful and it's very powerful. It's just how much of that power do you want to use? And it's GitHub Project Management specifically is really nice because you can use as little or as much of it, and it doesn't, the complexity ranges. So if you use only a little bit and use very little of the features, for example, just the cards and moving, it's not very complex and it's very easy to use. But if you want to use like full automation and include testing and unit tests and all sorts of stuff, you can actually implement that in GitHub Project Management. Probably for your cases, most of the time when you're, especially when you're starting off, you'll probably only necessarily worry with the very minimal, simple stuff just because you're starting off. Usually the other features are for bigger projects where you need to make sure code is running and it goes to a customer or whatnot. So I'd like to first go back into to show you GitHub projects, project management. So let me share real quick. Okay, so if you go up here, you'll see projects. You can click on projects, and then you'll see an example project. Now, you can create a new project, as you can see with this green button, or you can just click example project, which is the one that we're currently working on. And as you can see here, we have an example feature and an example bug. Now, if you'd like to move it over to done, it will automatically mark the task as, or the issue in this case, as done. We know it is not done. My bug is still an example bug, so I'm going to leave it in there. But as you can see, you can get kind of like a preview, and also if you double click, you can look at the actual card here and then make small modifications or go through the full issue if you'd like. And then you could also create just regular cards, for example, and these are simple cards which you can create into, these are essentially just notes that you can create into issues later on, or you don't necessarily need to create it into issues. You can just leave them as that, and this is more for simple stuff. Now, I also, so that's basically project management in a short time frame. There's obviously a lot more to it. These are kind of like the basics. And now we're going to go over a few like recommendations of how I would do everything. Now, first of all, I want to talk about pull requests because they're underused and underappreciated, but they're very, very useful. So pull requests, all they do is just merge code between two branches. Essentially, when you do git merge, that's what a pull request does. It just helps you merge from one branch to another. Now, in that case, why would you use pull requests if it's just git merge? Well, there's actually three main reasons. There's a lot of reasons, but there's three really main ones. The first one is to gives you a chance to stop developing and formally start testing your code. It is a time where you can sit down and say, okay, I have developed all this code, and before I merge it, I would like to test it one last time to make sure that it is working. That is, whether that is going through your tests or trying to break it, it gives you that chance, an opportunity, which you might not necessarily do if you're just doing a git merge on a command line. The second reason is to have, to give you the chance to have others test your code. Part of pull requests is that you can add a reviewer, you can add someone else to try and to test your code. So they can pull down your branch that you are working on and then test it to make sure it breaks. And in a lot of big companies, you'll see that in order to merge code or in order to accept the pull request, or sometimes it's called a code review, you have to have someone else accept it first. They have to say that, hey, yes, I have verified that this code works. So it gives other people also the chance to test your code and make sure that you've written good code in terms of your syntax and also that it works. And the third reason is that you document the process of development with others. So if you add someone else later on, they can go through your old pull requests and see what you did, when you did, and why you did it. So the final thing I'd like to go through is essentially a workflow. Obviously, there are a lot of ways that you can use Git. And I kind of touched up on this a little bit if you took 3001 last year and you saw my presentation. But I'd like to kind of bring it in, especially because when you're working with when you're working in a team, especially when you guys are far away, it's super useful and helpful. So we'll start. So essentially, I want to propose a workflow. It's my favorite type of workflow, using Git and GitHub or Bitbucket or Git, any type of Git server that you use. This would be applicable for. So as you can see here, we have feature branches, we have a develop branch, we have release branches, hotfixes, and master. Now, master is your main code base. It is the code that always works. If the professor comes to you and says, I would like to see your working code as you have it right now, you can change to master, you can switch to the master branch, and then run whatever code is in there, and it will be the most up-to-date, most stable code that you have. Now, occasionally, you find a bug in master, and that bug can be serious or not, and that's what a hotfix is. So you create a new branch, and that branch name is hotfix / and then the fix that you're trying to do. Hotfixes are things that, like bugs, where it's like, oh, I found a bug and I need to fix this as quickly as possible and then merge it back into master. So you see here, we've opened a new branch. This is a severe bug that we need to fix for production. And then when we do that, we would merge it back into develop, which is our main development branch, which we'll talk about in a bit. And then you merge it back into master with a new tag. Now, your develop branch, is your branch that you are working with for your development. And you'd like to try and keep this as stable as it possibly can, almost always. But sometimes it's a lot more likely for bugs to sneak in. It can happen. But it's essentially your chance to, it's your location to merge code from a bunch of different feature branches. So when you want to create a new feature or solve a new bug, you can create a new branch. As you can see here, this is a feature for future release or a major feature for the next release. And then you work on that feature, you make your commits, the dots are the commits, and then you can merge them back into your develop branch. And once you merge them back into develop branch, you essentially work off of that. And then finally, when you want to essentially take your branch and then merge it back into master, there are two ways of doing this. The way that I have here is you first make it into a release branch and then you merge it into master. That's not necessary for you guys, especially because you guys are working on a smaller project, but generally speaking, you can merge it into master directly, or you can create a feature branch or release branch specifically for the release that you'd like to do. So kind of an overview of the workflow. The first thing you're gonna do is create a new issue for a bug, task, or feature. So you can create a new issue in GitHub issues. From that issue, you can create a feature or bug branch. You would name the branch feature / and the branch name, or bug / the branch name. That helps identify what that branch is for. And then you would create that branch from the develop branch. That is very important. You make that you essentially spin off of the develop branch instead of the master. And then you code, develop your code, and then you test, make sure your code works. And then once your code works, you pull the changes and merge, you pull the latest changes in your develop branch. That is, if someone else worked on it, you want to make sure that you have worked on it on another computer and have pushed new changes into the develop branch. You want to make sure that you have the most up-to-date develop branch on your local repository. And then you merge your develop branch into your current branch. Now this is a little bit, this tricked me up a little bit when I first started, but it's really important. So especially now, you will be dealing with merge conflicts. And instead of being surprised when you're trying to do a pull request to find that you have a merge conflict, one way to do this is to just merge the develop branch into your current feature branch. By doing this, you essentially find all of your merge conflicts before you actually create a pull request. And then you merge your develop into master, or you merge. Then you would essentially take your branch, then merge it into develop using a pull request, and then at some other point when you want to, when you've reached a milestone, let's say you are done with lab 1, you can merge that develop back into master. Okay, and so that concludes my presentation. There are a lot more features, like I said, in GitHub that I didn't go over today. For example, one of them is milestones. And the best way to learn, in my honest opinion, is to just start and use it, and you'll learn your own way of what works for you and what doesn't, and you'll develop your own way of working remotely with others and your own preferences. If you have any questions, feel free to drop it in the chat.